Start again. Hi, this is Alex Glasgow. Today I'm going to talk about soil test units. What do they mean? Because you will see there's quite a few different units and can be a bit confusing. So we want to be able to make sense of the soil test results, and so understanding the units is an important part of that. And then the key thing about soil test results is to be able to turn those numbers, the results, with the unusual units or into practical actions such as the application of fertilizer. So, how do we do things like convert units such as milliequivalents per 100 grams or parts per million, that's ppm, parts per million, or milligrams per litre, or percentage BS, which is base saturation, into kgs per hectare. And obviously kgs per hectare can be converted into actual amounts of nutrient that you're going to apply. So just wanted to have a quick look at some soil test results just to show you a few things here. The first one's actually not to do with the units, it's actually just to do with pH and a couple of different ways of testing pH. You can see here there are two pH results. Each one of these columns is the results of testing done on a soil sample submitted to the lab. So you can see here we've got the top one, pH units, it says, and the next one down says calcium chloride pH. The one at the top is done in a water solution or extraction into water, and that's tested, and this one's done into a calcium chloride solution, and that's tested. Now they're just two different ways of determining the pH. I'm not sure why you use one in preference to the other. There'll be certain circumstances where the other one's more applicable, but normally we just use this water extraction, but this one's use the calcium chloride as well. So the key point to note here is that there are two different results. You can see they're quite different. The water extraction gave in this case a pH of 7.3, and the calcium chloride gave one of 6.6. So they can be quite different depending on the exact method of the determination. So that's important to bear in mind if you want to be able to look back at old test results and compare to where you are now. It's important to carry on using the same methods of determination. Okay, this next one here, we'll talk about the units here. Olsen phosphorus, Olsen P, it says mg per litre or mg per L, which is milligrams per litre. That's what that actually means. Next one down there, potassium says ME per 100 grams. That means milliequivalents per 100 grams. And just in the last one of these, I talked about these different results here. You can see for potassium and then for calcium and magnesium and so on. You've got results in units of ME per 100 grams, percentage BS, and math units. In this case, the soil analysis has been done once only, and all these different forms of the result have been calculated from the extraction that they did. So they do one extraction and then they can calculate it in different forms. But then further down here, you'll see we've got some more results, and these are in what's known as Malich 3. So this is a different method of extraction altogether. So it's in this case, the soil has been tested twice, essentially, one to get these results up here and down here to get these Malich results. You can see here that the units in the Malich are familiar with this one up here. It's milligrams per litre also. Okay, so let's just have a look at some soil test units that you may well see on a soil test result. You can see there on a weight basis, that little U there, that means micro, so micrograms, which is millionth, basically. So micrograms per gram. Then we have this next one, which is the M means milligrams per kilogram in this case, milli meaning 1,000th. So if you think about a millimeter, there's 1,000 millimeters in a meter. So that's milligrams per kilogram, and then another one is grams per ton. Those are all the same, and they're all parts per million, ppm, parts per million. And then on a volume basis, we've got some more. We've got micrograms per milliliter. We've also got milligrams per litre, and grams per meter cubed. They're all the same, and they are all also parts per million. Okay, so what about this one here? This is one we talked about before, milliequivalents per 100 grams. What about milliequivalents per 100 grams? We can convert this to ppm. Unlike the other ones, this is not a parts per million equivalent, but we can convert it to parts per million with the formula below, which is parts per million equals milliequivalents per 100 grams. That's the number from the soil test result, times a constant, and the constant is there is a constant for each of the nutrients. So, for example, 391 for potassium, 200 for calcium, and 122 for magnesium. So to do this for potassium, and we got a soil test result of 0.3 milliequivalents per 100 grams. So to work out potassium in parts per million, we go 0.3. That's the milliequivalents per 100 grams number from the soil test result, times 391, and that equals 117 parts per million. So that's just to illustrate that you can convert that milliequivalents per 100 gram result to parts per million. I'm going to wrap it up there, and next time what I will talk about is how you can take these parts per million results and convert them into something that is more meaningful, which is kilograms per hectare, because obviously once you start to talk in terms of kilograms per hectare, and so for example you can work out how deficient the soil is in terms of kilograms per hectare, you can then work out a fertilizer amount to apply to correct that deficiency. So I'll wrap it up there, and thanks for listening.